One is an addition. Then this also.
Yeah.
Pretty great. That gives the. I don't know.
Okay, if we can turn to worksheet 2. I think we got halfway through worksheet 2, so we'll finish worksheet 2, and hopefully we can also finish worksheet 3. And again, your quiz is tomorrow. You will be given these identities that you see at the top of the page. I will include that at the top of your quiz page.
Yeah.
Okay. So again, 5 problems on your quiz. You can work through all 5, but you're going to have to cross out the one that you don't want me to grade. Okay. But there is a bonus as well. That bonus you can choose to do or not do. You don't have to do that one. So there's 6 problems total, but you only have to do one. Okay. That makes sense. Also, probably that you don't want graded. I'll leave this up on the board for now, but tomorrow I'm going to erase this. We can continue to use this as we look at ways to help us through the problem. Right, so rewriting as sine and cosine, looking for trig identities. Sometimes there's some problems where we're kind of making something out of nothing to get a trig identity to show up. So I want to talk about a little bit more with that process. Combined fractions, sometimes common denominator can push us towards the wrong side. Sometimes splitting fractions can help us move towards where we want to go. Factoring can also, either GCF or difference of squares or trinomial factoring may allow us to group expressions in a way that will cancel and reduce. And then if you see parentheses, sometimes expanding can help us get there. So worksheet 2, we did the first page. So let's go through, work on 5. Okay, so number 5, maybe a way that we can do this. Let's see, any ideas for the let's see, split into fractions. Yeah, but there's 2 terms here. I don't know if that's going to help us. But yes, I mean, we could split into fractions, but the fact that there's 2 terms below, it's going to make it kind of messy for us to do anything with it. But maybe I'll do 2 fractions. If there's only 1 term below, then I'll maybe do that. But there's 2 terms, so I don't know if the benefit is going to be there as much. Cosine and sine, okay, that's what I was thinking as well. There may be another option as well, but let's explore that one first. Let's explore sine and cosine. Maybe that will create fractions enough to simplify all the way. Okay, so let's see what happens there. Okay, common denominator for my top half is going to be what? The sine x, right? That's nice, right? The denominator is already paired up, so I can just merge that fraction pretty quickly.
All right, what about my bottom portion there? It's my common denominator. Cosine x, so I need to balance some fractions here. Any adjustment needed here? Nope, keep the 1. Any adjustment needed here? Yes, multiply by cosine x. Okay, now that I have a fraction over a fraction that's nice and clean, I can multiply by the reciprocal of the denominator. Times the reciprocal. Okay, what do you see here? Goes away. Let's put the remaining terms in its own fraction. Right, and what's cosine over sine? Equal to what? Cotangent, and that's our, we can stop there. Okay, any questions there with 5? Yeah, I worked it out a different way on the key. I multiplied the top bottom by secant x plus 1. And yeah, I'll talk about a little bit later how we can make something out of nothing by either multiplying by the conjugate or multiplying by the single functions to make it squared. So okay, let's look at 6. All right, anything stand out? Yeah, I see an identity here. Okay, what's 1 plus cotangent squared equal to? Cosecant squared. And sine and cosecant are reciprocals, so they're just going to multiply to be what? 1, right? Or if you want to show a little bit more work to convince yourself, you can rewrite cosecant squared as 1 over sine squared. That's fine as well. Okay. Number 7. What about number 7 here?
Change the sign or cosine.
Uh,
Split it up.
yeah, so this is where I would think is a good candidate for splitting up. There's only one term below, there's multiple terms above, and I have 2 terms on the right side. So I think that is a good, yeah, so we can kind of see that when splitting up can be useful. Okay, 1 over secant squared, the same thing as. Then secant over secant is same thing as 1. So we have our result. Number 8. Okay, what are you thinking here?
Sine cosine.
Yeah, kind of giving away giving it away on the right side, right? Well, if everything is sine and cosine, then this should get us to where we want to be. So each individual fraction, we can multiply by the reciprocal. So we can try to treat each like its own independent space. And we should be able to get each fraction cleaned up. Okay. Does that work out to be the right side? Cosine goes away. Sine goes away, right? These are 2 separate fractions, so we can kind of handle them independently. This side becomes sine theta. This side becomes cosine theta. Okay, worksheet 3. Let me point out a couple of things here. Sometimes if you're taking the quiz and you just feel like you're stuck and you're just having trouble working from one side, you can maybe try starting on the other side. Okay, you can definitely do that as well. I'm saying that you can't work from both sides, but sometimes that is a possibility just to kind of get things started, right? If you can kind of work from both sides and kind of meet in the middle, maybe that will kind of help you work backwards to kind of eventually get from one side to the other side. Okay, so so those are just options to kind of help you brainstorm a little bit, especially if you're stuck. But ultimately, I'm going to be grading on that you're working from one side and reaching the other side. Okay, typically I would say from left to right, but if you're stuck, if you need a separate sheet, you can definitely try to work from right to left, and I can look at your work, and if you can do that, then you get full credit there as well. Yeah.
So like you want us to like put the steps in like a row so we see
Um,
the steps we take.
Not necessarily. I mean, I'm assuming that, once you begin the process, everything is going to be from that side moving to the other side. So you can just show your work any way you want, but just show me your steps. Tomorrow I will put scratch sheets up near the phone, so you can definitely go and just grab scratch sheets if you feel like you need extra space to practice and or try different things, right? That you don't want to put onto your paper yet. All right, so number one, what do you see? Say it again. Distribute through. Yeah, you're right. If I distribute through, it's a trig identity. Another possibility that I was thinking is replace the 1 minus cosine squared as sine squared and multiply that out. That will give you tangent squared. So here, yeah, there's multiple ways. Okay, so as you get more and more comfortable, you're going to discover there's more than one way to get to the end. And as long as your steps are valid, you'll earn full credit. Okay, so don't feel like there's only one way to get to the end here. But yeah, the key I have replacing the parentheses as sine squared, but you can definitely distribute through and that will work too. All right, number 2. How would you start this one? Say it again. Maybe, maybe that will get to the end, but I'm looking at something else. I think that will speed this up faster. Okay, let me ask you this: how many terms do you see? 2. Right, that minus sign is separating the 2 terms. Okay, what do you notice about the 2 terms? Anything? They both have what? Yeah, GCF, right? So I think that's something that we tend to not see as clearly. I think our natural tendency is just sine and cosine. I think that could work, but I think that will take a lot longer, right? If I just take that GCF, I think that will speed my process a little more. So if you take out a GCF of cotangent squared, remember that you're not subtracting cotangent squared away, you're dividing cotangent squared away. So if it helps, you may want to, give yourself a visual reminder that you are actually dividing the cotangent squared, and then whatever remains is going to be left inside the parentheses. Okay, so if I were to divide the cotangent squared out, what's left? Cosecant squared. Yep, and then the cotangent over cotangent just becomes 1, so good. All right, what's nice about this parentheses here? For identity, cosecant squared theta minus 1 is equal to cotangent squared, and that will get us to the end, right? It's the first step that's hardest, right? If you can get that first step down, everything kind of falls into place. Cotangent squared. I add the exponents if I multiply the bases. Okay. Number 3, what do you think about number 3? Yeah, common denominator, but there's something that that we should maybe take care of before we do common denominator. Yeah, let's take care of that secant. You see, everything in terms of sine and cosine. That secant is gonna cause some issues later. And if I can get that in terms of sine and cosine, I think it'll kind of set my expression a little cleaner. So yes, common denominator, but it'll be better if I take care of that secant first. And then I can do common denominator. So secant is 1 over cosine. 1 over cosine divided by sine is really 1 over cosine times sine over times the reciprocal, right? So let me do this here. So 1 over cosine theta times the reciprocal of sine, which is 1 over sine, which is 1 over cosine sine. Okay, so I'm going to rewrite it here. My fraction has now turned into this. Or in other words, you can think of it as flipping that secant as cosine down to the bottom to share that space. So now this is what I have. I have 1 over cosine sine minus sine over cosine. Okay, feels a little bit cleaner. The denominator is a little messier, but at least everything's in terms of sine and cosine. Okay, what's my common denominator now? Now that I want to merge the two fractions together, what's my common denominator?
Cosine sine minus then sine cosine.
So we want something large enough that both can go into. So our common denominator will just be what?
Cosine squared.
We don't need cosine squared sine. I think cosine and sine is good enough because if you think about it, cosine and sine can be a part of this, and then cosine can be a part of this as well. Right, so we don't need something because these are duplicates. So as long as it's large enough for both to go into. Now, if this was like cosine theta minus 1, then that's completely different, and we're going to have to create two completely separate denominators. But here, because these are both in a sense shared, we don't need as much. Now, if you did cosine squared sine, yes, eventually it'll still work out, but you've got to do some cleanup down the road. So we just need something large enough that both can individually be a part of. All right, any balancing needed here? What do you think? First fraction, any adjustment needed? Just bring down the 1. Okay. Second denominator, any changes needed?
Sine.
By sine. Sine times sine is sine squared. Merge as one fraction. Okay. 1 minus sine squared. What can we do with that? Make it cosine squared. Okay, we're getting closer. What do you see from here? Yeah, take out one of the cosines because above this really cosine times cosine. But I'm just going to remove the squared and take out one of the cosine here. And then cosine over sine is cotangent. Okay, number 4. Right, find what? Common denominator, right? Okay, what's our common denominator? And sine. Yeah, so we need both of them, right? These are completely different things. We're just gonna have to keep both of them and call them, include them both as common denominator. Balance each fraction. Compare denominators here. There's a difference. Sine theta. Multiply sine and sine, I get sine squared. Compare denominators. Yeah, I'm needing that 1 minus cosine, so top by 1 minus cosine. Right, I'm going to fill this out. So I can just save a step here. So if I distribute the 1 minus cosine, I get 1 minus cosine theta minus cosine theta plus cosine squared theta. Oh, sine squared theta, sorry. All right, everything can go under one fraction. Okay, let's clean up the numerator. I'm not going to FOIL the denominator. I think that 1 minus cosine is going to be helpful down the road. What about the numerator here? Sine squared and cosine squared becomes what? 1. And then 1 plus 1 is 2. Yeah. All right. Seen this problem before. Okay. What can we do with the numerator to get it to look a little differently? Factor, right? GCF of 2. So if I divide both terms by 2, 2 divided by 2 is 1. 2 cosine theta divided by 2 is just cosine theta. Cancel, cancel. 2 over sine is the same thing as what? Yeah. Okay, 5 through 8.
So on a test, you know, if there's 5 problems, what do you like mostly maybe like the 5 be like different types of them?
Yeah, it's gonna be a range of ones that you see here, right? Just a variety of
So
problems.
then you go ahead and use all those at least like once.
I'm sorry.
Can you go ahead and use like at least one, like all those at least once, or like
Maybe.
most of them? Oh,
Yeah. So, yeah, I would say, you know, be comfortable with each of those possibilities. Yeah, and I think we're seeing all of them show up here, right? All right. Okay, 5. What do you think? First step. Common denominator. Okay. Note the difference between the old and new denominator. And then whatever is different has changed. That's what we got to include to balance our numerator. Okay, distribute the cosine through the 1 minus sine theta. Okay, compare my second fraction, second denominator. The difference is that 1 plus sine theta, so I need to multiply the top by 1 plus sine theta. All right, combine everything as one fraction. Okay, what's nice about the numerator? What cleans up nicely here? Cosine sine goes away. I'm left with 2 cosine theta, and then the denominator, what do you think we should do with the denominator here? Yeah, let's spoil it out, right? It doesn't look like the numerator is going to produce anything that I can cancel out with these parentheses, so that's going to help me to kind of guide my steps to maybe foil out, give me a different look of that denominator. So okay, denominator, what can we do there? Make it what? Okay, then what can we do with that 1 minus sine squared? Yep, identity. Okay, can I reduce? Okay. So reduce, that leaves me with what? 2. What happens here? So I have 2 cosines below, so I can take out 1 from above and below. So I'm just left with 1 cosine theta, right? Because really that cosine squared is just cosine and cosine. So I'm left with 2 over cosine, which is the same thing as flipping that up and making it 2 secant. Okay, cosecant to the 4th minus cotangent squared to the 4th. Does that ring a bell? Does that look like anything that we can handle?
Fine.
All right. Let me give you this example here. What if I gave you a to the 4th minus b to the 4th? What can we do with that? So let me make some connections here. If I gave you a squared minus b squared, we can break that down into what? Perfect squares of each. Into a minus b times a plus b. Okay. Can I do the same thing if I had a to the 4th minus b to the 4th? All right. I can break them down into their square roots. A squared minus b squared. A squared plus b squared. Right. Difference of squares, just my powers are a little higher, but I'm still going through the same process. Right. So can I do that same thing here? So a to the 4th minus b to the 4th is a squared minus b squared over a squared plus b squared. So I'm just going to combine the two and take turns with the signs. There's my factored form. All right, is there a quick identity that we can deal with right now? Which one is the one? Yeah, cosecant squared minus cotangent squared is equal to 1, so that goes away. So that just, right, we can just ignore that. Anything that's 1 is just basically disappeared. So I'm just left with cosecant squared theta plus cotangent squared theta. All right, we simplified to this point, but look at the right side here. We want the right side in terms of what? Cotangent squared, so what could we change? Change the cosecant squared, right? Is there an identity that we can replace that with? Cosecant squared is 1 plus cotangent squared, right? Make that substitution. And then bring down the cotangent squared from above and merge the two common terms there, two like terms. Okay, number 7. Let me point you in the right direction here. What does that look like to you? Trinomial factoring. Okay, so let's do a simpler problem of that expression. Let's do x squared plus 2x minus 3. I realize that many of you guys learned factoring using grouping method, so I'll show that step. If you want to do grouping method, a times c is -3. Your b value is 2, so you're asking yourself, what multiplies to be -3 and adds up to be 2? What are the two numbers there? 3 and -1, right? 3 and -1. So what we can do is take that middle term and split up into, in terms of 3 and -1, but keeping the x. It doesn't matter which order you do it in, it's going to come out the same way. And then look for GCFs in each pair. -1 is my GCF there, so really I'm dividing by -1, which is going to change the sign there. Okay, you know you're on the right track if you can find a shared parentheses. So take that shared parentheses out, and then the terms that are not in parentheses will get its own set of parentheses. Okay, so there's your factored form of your trinomial. Yes. Yeah, star method. Yeah. So star method would be this. Multiplies to be -3, adds up to be 2. We have 1 and 1 because my coefficient is 1. And then multiplies to be -3 and adds up to be 2. We found that to be 3 and -1. Get your x's in place. 3 over 1 is just 3. -1 over 1 is just -1. So +3 -1. So we're factoring a simpler problem. Let's bring cosecant back into our expression. Okay. And what can I do with cosecant squared theta -1? I don't want to use an identity because looks like I'm staying in terms of cosecant, but in terms of factoring, what can I do? Difference of squares, right? So cosecant theta minus 1, cosecant theta plus 1. Okay, so basically, I factored the numerator and denominator. I found some common parentheses that I can remove. And my resulting expression is the right side. Yes.
X squared plus 2x minus 3 to x.
Oh, that's grouping method. If you want to factor with grouping method, you can go through this method. But if you're comfortable with star method, then you can just go from here to here. Is that how you factor with star method or with grouping method?
Like minus 2 minus 1.
You can do. Oh, you mean the final factored form? Well, I need to be able to multiply to be -3 and adds up to be 2. So what did you say again?
X minus
Okay, the issue here is if I were to FOIL this out, I would get x squared minus 3x plus 2, and that's not the same thing as this. Okay, number 8. Did we see this problem already? No, I haven't. But this is easy, right? What can we do here? Yeah, split it up. Hey guys, let me just point out a few quick things here. Some more strategies that I think that can prove helpful. So here's one of them. I don't have a specific problem in mind here, but I just want to say that, sometimes if you want to make something out of nothing, you can multiply the top and bottom by sign to get an identity to show up, right? Guys, give me just one more minute here. So we know that we can make something out of nothing by multiplying by sign to get that sign squared, and sometimes that can help move the problem along because you have some identities available to you. Here's another option here. Let's say I had sine of theta over 1 plus cosine of theta. Another option that you could do to make something out of nothing is multiply it by the conjugate of that denominator. What's the conjugate of 1 plus cosine theta? 1 minus cosine theta. If you do that, you can also make something out of nothing, because if I were to FOIL this out, I would get 1 minus cosine squared theta, and that will also give me an identity to play with. Okay, so sometimes multiplying by either sine or multiplying by the reciprocal can jumpstart your problem to give you a different form to play with. All right, look through your notes. Quiz is tomorrow. Okay, don't forget your phones.
I have a question. I just did it in my own. I got secant plus theta over 2 secant. Is that right? Like, is that equals to 2 secant?
Yeah,
Okay.
you take out 1 secant and then,
It's if we're just multiplying.
but then that 2 should be up here. That 2 looks weird. Okay, if you want to make 2 cosine theta into secant theta, the 2 stays above, but the secant theta goes below. I can't make this 1 over 2 secant theta.
Really?
Because 2 cosine theta is this is not the same thing I didn't say.
Do you have any worksheets of additional practices I could